this webinar, part of Eminence 5.0, organized by the IEEE Affinity Group of the IEEE Student Branch at the University of Ruhuna. We are delighted to have you join us for this continuation of the AI series. Today's session will further explore fascinating topics in artificial intelligence. At the end of the session, you will have the opportunity to ask your questions. Without further delay, it is my pleasure to introduce today's speaker, Mr. Dinu Patiraja, final year computer engineering undergraduate at University of Ruhuna. We are excited to have him here to share his knowledge and experience with us. Mr. Dinu Patiraja, the session is now yours.
Okay, thank you. I think you guys can hear me, right?
Yes, we can hear you well.
Okay, let me share my screen first. Okay, I will introduce myself first. My name is Dino, and you know that I'm a final year student undergraduate at Department of Computer Engineering. Okay, first I want to get some insights about your batch and all the things that you know so far. So can you guys log into the Slido platform and enter this code and log into the platform and answer some questions that I will provide. I will provide the questions. These are simple questions. You can provide the answers. This is like a poll to get the insights. The platform is Slido. You can go to Slido and enter the code that I have shared in the chat, Zoom chat. And can someone confirm that? Can you see the questions? Okay, I think yeah, you can vote now. Yeah, please vote. Okay, majority are from 24th and 25th batches, I think. Okay, there are 9 votes. Can you guys quickly vote? There are only 10 votes. Can you guys quickly vote? Okay, I think majority are from 24th and 25th batch. Okay, the next question is this. You can see the second question, right? Have you any experience in machine learning, deep learning, Python notebook creations? Okay, okay, okay. Majority vote counted as no. Okay, the next question is this. Yeah, I think all good. Yeah, some have ordered to do it in single as well. I will try to do it doing both the languages. Okay, okay. Thank you very much. Now you can stop recording. Let me quickly go to the presentation. Mm, yeah, I think you can see my presentation well. First, in your previous webinar, you have learned what are the three types of machine learning. The machine learning paradigm can be divided into three types. The three types are supervised, unsupervised, and reinforcement learning. Can three of you explain what are the supervised, unsupervised, and reinforcement learning? First, what is supervised learning? You have learned it in your previous webinar. Can one of you unmute yourself, or else you can put it in the chat as well. Anyone? Can't you remember? You have learned it in your previous webinar, I think. You can use the Zoom chat. I don't mind. You can use the Zoom chat if you don't want to talk. You can use the Zoom chat. What is supervised learning? Actually, you have the answer here as well. Are there anyone? Or else I will explain. Okay, I will explain in brief. What is supervised learning means? We have to, in supervised learning, we have to label our data. Using labeled data, we are predicting the results from the model. We train the model using our labeled data. That is supervised learning. And unsupervised learning means we don't use labels. We let algorithms to decide what are the relationships in the data set that we provide. We let the algorithms to decide what are the relationships? That is unsupervised learning. And the next one is reinforcement learning. This is different from other two. This reinforcement learning is kind of an agent is learning according to the feedbacks. That's a different type of machine learning. Let's go to the today I'm doing just the supervised learning part, and in the competition also we are giving you the supervised learning questions. First, regression versus classification. Supervised learning also can be divided into two parts. First one is regression, and second one is classification. What is regression? As you are many of you are from 24th batch, I think some I don't know I can't remember that you have done the mathematics module in the regression analysis. I can't remember. You maybe no. Sometimes you may know. Here the regression analysis means let's assume you have two data xy plane in xy plane. As an example, let's say for a regression analysis, we are predicting house prices. For a house prices, to change house price, there can be many factors affecting to the house price change, according to the location, according to the square feet of the area of the house, and many more factors. Let's assume those features as x1, x2, and x3. Let's first take only one feature, that is x1, and the prediction is predicted value is the house price. That is a numerical value, not a categorical value. We are predicting a numerical value. That's why it is called regression algorithms. Okay, let's now we say x1 feature is the square feet of the floor. Let's assume as that, and y1 is the not y1. Y is the price of the house. Let's say there are some data points like this. Now you can draw a line. Now you can draw a best fit line through these data points. You know that this the formula of the function will be y equals mx plus c. This is the formula, and you know that you can draw a best fit line through these data points. Now from these data points, now you can find m and c. Now you know the formula. Let's assume as 2x plus 5. This is the formula. Now for a given price, we took x as the square feet. We took x as the square feet of the area of the house. Now for a given square feet, let's assume x as 5. You can predict the house price. Can you understand? I will explain in Sinhala as well. මෙතන regression analysis කියන්නේ ඔයගලන්ට තියෙනවානේ ඔයගලන්ට ගන්න පුළුවන් features. අපි හිතමු x කියන්නේ එක feature එකක්. ඒ කියන්නේ square feet එක ගෙදර තියෙන ගෙදර පොළවේ square feet එක අනුව price එක වෙනස් වෙනවානේ ගෙදරක. එතකොට එහෙම ගත්තොත් x කියන්නේ price එක නම් y කියන්නේ ඔයගොල්ලෝ ගෙදර ගාන, ගෙදර මුදල. එතකොට ඔයගොල්ලෝ මෙතන ගන්න පුළුවන් best fit line එකක් ඇඳ ගන්න පුළුවන්. මේ data points ගත්තොත් මේ data points අනුව best fit line එකක් ඔයගොල්ලන්ට ඇඳ ගන්න පුළුවන් graph එකේ. එතකොට ඒ ඇඳට පස්සේ ඔයගොල්ලෝ දන්නවා සමීකරණය. mx ධන c වල m එකයි c එක ඔයගොල්ලෝ දන්නවනේ අනුක්‍රමණය අන්තක්කණ්ඩය. දෙක හොයන්න දන්නවනේ. ඒ දෙක හොයාගත්තට පස්සේ එනවා මෙහෙම සමීකරණය. එතකොට ඔයගොල්ලෝ සමීකරණේ x දන්නවා නම් y හොයාගන්න පුළුවන්. ඔන්න ඕක තමයි simple විදිහටම regression algorithms වල වෙන්නේ. ඒ regression algorithms වල algorithm එක finally හොයාගන්නවා මේ වගේ best fit සමීකරණ. ඒ සමීකරණයෙන් prediction එක දෙන එක තමයි regression analysis වල වෙන්නේ. එතකොට let's assume there are many features. There can be many features like square feet, and there can be many features to affect the house price. There can be many features like x1, x2, x3, so many features. Then you can draw a graph like this. Then the algorithms predict. The algorithms use the provided data set, and he get a he get a formula like this. මේ වගේ සමීකරණයක් හදාගන්න. අපි හිතමු features 3ක් දුන්නා කියලා. If we give 3 features, the algorithm finds the best formula that suitable for that specific data set. We are giving a data set. For that specific data set, he is finding the best formula. Okay. Now you know what is regression analysis means. This is actually this is linear regression. Okay, this is linear regression algorithm. Regression analysis means you are predicting numerical values, and linear regression is like this. If the relationship is linear, if the relationship between the features are linear, we call it's a linear regression algorithm. We predict linear regression. We predict a numerical value from this linear regression algorithm. And another regression algorithm is decision tree regression. This is a simple algorithm. This is a tree, and there are, you can see in these boxes, there are conditions. According to the data sets, according to the provided data set, we are providing a huge data set. Like there are 10,000, 50,000, like huge amount of data. No? Then from those data, it goes through these conditions and create a graph. Created the graph. Now, when you input the data, new data, it can predict through this graph. This graph has some values. No? From the training data, it has taken some values. It has updated these values. It has updated. From that, it will predict the values. That is also another linear regression. That is also another regression algorithm. Okay. Let's go to classification algorithms. These are different. Previously, in the regression, we predict a numerical value. That's examples are predict the house price. Like the house is 3 lakh, 5 lakh, 10 lakh, like that. Or else predicting stock prices. That is also a regression algorithm. Regression type of problem. And the next one is classification. Classification is different. Classification means you can classify dogs and cats. That's a classification type of problem. And email is a spam or not. That is also a classification problem. And one student is selected for a job or else not selected for a job. Like that, you can do classification from this classification also from this machine learning algorithms. Let's say what are the classification algorithms we have. Here are also two popular classification algorithms. First one is logistic regression algorithm. Here also the same, like that. You have some features. Let's assume you have X feature and the predicted class is Y. Okay, this is the graph, and the formula of the graph is this. Formula of the graph is this. Don't worry about this formula. You will learn these formulas in your mathematics modules. So don't worry about that. Just keep in mind this is the formula. Okay. Now here this works as we get a threshold value. Let's assume we get the 0.5 as the threshold value. Now you can say if the predicted value is larger than the threshold value, you can say it belongs to this class. If the predicted value is smaller than threshold value, you can say it is belong to other class. සිංහලෙන් කිව්වොත් මෙතන logistic regression වලදී වෙන්නේ ඔයගොල්ලෝ ගන්නවා මෙතන threshold value එකක් දෙන්න. threshold එක කියන්නේ ඔයගොල්ලෝ ඒ threshold එක කැමති value එකක් දෙන්න පුළුවන්. 0.5 වෙන්න පුළුවන්, 0.2, 0.8 කැමති එකක් වෙන්න පුළුවන්. ඒකේ එතකොට ඔයගොල්ලෝ ප්‍රෙඩික්ට් කරනවා දැන් මේ ඇල්ගොරිතම් එක යූස් කරලා data fit කරලා ඇල්ගොරිතම් එක යූස් කරලා data fit කරලා train කරලා අප ප්‍රෙඩික්ට් කරද්දි ප්‍රෙඩික්ට් කරන value එක අපි හිතමු මේ threshold value එකට වඩා අඩුයි. කියන්නේ අපි threshold එක 0.5 කියලා ගත්තා නම් threshold value එකට වඩා අපි හිතමු එන prediction එක 0.4යි. එතකොට අපිට ගන්න පුළුවන් මේ class එක අපි හිතමු yes. අපි හිතමු මේ class එක no. මේ class එක yes. එතකොට අපිට ගන්න පුළුවන් 0.4 නම් එන්නේ මේක no එක. 0.6 නම් එන්නේ මේක yes එක. එතකොට එහෙම ගන්න මේක that is a classification. Sorry. And the next one is support activation. Here it is a bit different. Here the graph is drawn for the features. Let's assume in the example, let's say a student is selected for a job or not according to his let's say features are age, if he has work experience or not, like that. Let's assume these age and work experience are two features that affect to the selection of that student. Let's assume that. Now the x1 is age and the x2 is work experience. Okay. Now we can assume that this data is spread in the graph like this, and we can draw a hyperplane dividing this data. Clearly dividing this data, we can see that these data belongs to one category. This data belongs to another category. You can see. Now we can draw a hyperplane. If you know this hyperplane's formula, you can see, you can predict the value if the let's see. Okay, the form according to the formula, you can say if the value is lower than this formula's value, then it belongs to this. If it is larger, it belongs to this. That is also classification. This is no class, then this is yes class. The student will be selected, student will be not, like that. Okay. සිංහල කිව්වා මෙතන support vector machine කියන්නේ තව classification algorithm එකක් උඩ statistic regression වගේමයි. ඒතකොට ඒකෙත් කරන්නේ මේ features අපි හිතමු වයසයි work experience උයි මේ වගේ features දෙකක් තියෙනවා නම් ඒ features දෙකට ඔයගොල්ලෝ graph එකක් අඳින්න පුළුවන්. මේ algorithm එකෙන් මේ automatically වෙනවා. මේ graph මේ සමීකරණය හොයාගන්න එක algorithm එකෙන් automatically කරනවා. ඒක ඔයගොල්ලෝ කරන්න ඕන දෙයක් නෙමෙයි. ඒක data point ඔයගොල්ලෝ දෙන data අනුව එයා best fit line එකක් හෝ best fit formula එකක් හොයාගන්න එක තමයි කරන්නේ. ඔයගොල්ලෝ මේ අර ඒක ඇතුළේ වෙන දේ ඉගෙන ගන්න එක තමයි මෙතනදි කරන්නේ. ඔයගොල්ලෝ දන්නේ නැහැ නේ ඇල්ගොරිතම් එක ආවද? මැෂින් ලර්නින් කියන්නේ මොකක්ද? මැෂින් ලර්නින් වලදී වෙන්නේ මොකක්ද කියන එක දැන් ඔයගොල්ලෝ දන්නේ නැතුව නිකන් ඇල්ගොරිතම් එක ඇප්ලයි කරලා data අරගෙන ට්‍රේන් කරාට වැඩක් නැහැ. ඔයගොල්ලෝ දැනගෙන ඉන්න ඕනේ මොකක්ද මේ ඇල්ගොරිතම් එකේදී වෙන්නේ. කොහොමද මේක මෙහෙම ප්‍රෙඩික්ෂන් එකක් දෙන්නේ. හරිද? දැන් ඕකම නොකට කියනවා මට වචනේ මතක නැහැ. sorry explainable. ඕක දැන් ඉස්සරහටත් යනකොට ඔක LLM වලටත් යද්දී දැන් අපි මේ machine learning ඊට පස්සේ දෙනවා deep learning. ඊට පස්සේ LLMs. ඔය ඉස්සරහට යනකොට ඕවා අපිට මේ black box වෙනවා. මේ machine learning algorithms වල අපිට කියන්න. ඊට පස්සේ දැන් මෙතනින් ඉස්සරහට යනකොට මේවා වෙනවා artificial neural networks, convolution neural networks. ඒවා sort of black box. ඒවා train වෙන්න weights වගේ ඒවා අපිට කියන්න බෑ මොනවද කියලා. ඒකට අපිට ඒවට explainable AI දාන්න පුළුවන්. ඒක ලොකු ඩොමේන් එකක්. ඒක මතක තියාගන්න කියනවා. AI වල වෙන දේවල් අපිට AI එකක් කියන්නේ මොකද්ද මේ ඇල්ගොරිතම් එකේ වෙන්නේ මොකද්ද කියන එක අපිට එක්ස්ප්ලেইন කරන්න පුළුවන් වෙනවා. ඒ කියන්නේ අපි දැනගෙන ඉන්න ඕනේ AI එකක් කරන්නේ මොකද්ද කියලා. හරි. ඕක තමයි එතකොට ඇල්ගොරිතම්ස් දෙක මම අද කතා කරන. මම හිතනවා මේ දෙක තේරුම් නැති කියලා. මොනවායි ප්‍රශ්න තියෙනවද? If anyone has questions, can you put it in the chat? I will give you 2 minutes. Are there any problem from the things I have explained? If you have any problem, please ask. I will give you 2 minutes. ඔතන හරි පොඩි හරි තේරුම් නැත්නම් තියෙනවා නම් මගෙන් අහන්න ප්‍රශ්නයක්. විනාඩි 2ක් දෙන්න. තේරුණාද ඔක්කොටම? හොඳයි. No questions? Yeah, I think no questions. Let's go to this is end-to-end ML workflow. This is how we create a notebook and train machine learning model and get an inference and save the model and get an inference. This is how the workflow goes. Let's understand the workflow. First, you have to load the data. Load the data means you can sorry. The data sets can be so many sources. You can take data sets from the data may be from images, and also data can be Excel files or CSV files, anything, voice files, anything can be data. So loading the data is the initial step. Then next one is EDA. EDA is the another main part, main thing. This is yeah, EDA. This is explanatory data analysis, exploratory data analysis. I will explain what is exploratory data analysis in the notebooks. Then preprocessing. Preprocessing also very important. Before feeding the model, before feeding the data to the model, to the machine learning model, we have to preprocess the data. That is a very crucial part. You have to understand that how to do the preprocessing. Next one, feature engineering. Feature engineering can be necessary in some cases or unnecessary in some cases. Feature engineering, I will explain what is feature engineering. Next one is choosing the best model, training model, evaluating model, hyperparameter tuning, and select the best model. Those are the end-to-end machine learning workflow. What is the first one? Load data, EDA, then pre-processing, feature engineering, choosing the model, training the model, evaluating the model, hyperparameter tuning, and finally selecting the best model. And there can be another one, that is inferencing. Inferencing means getting a prediction from the best model, best saved model. That is the end-to-end workflow. Okay. From this presentation, are there any problem for you guys? This is the end of the presentation. I will next go to the notebooks. This is the end of the presentation. If you have any questions, you can ask now. I will give you one minute until I share the notebooks. I will give you 1 minute. If you have any questions, you can ask. Are there any questions, guys? No. Someone is asking, is the pipeline same for all supervised and unsupervised learning? No. The pipeline is different. In the pipeline, there are many things you can include in the pipeline. Pipeline you can include encoding and scaling. You can include many things to pipeline. So in supervised and unsupervised, there can be different. The pipeline can be different, not the same pipeline. In unsupervised learning, you are clustering the relations. You are clustering. That means clustering means you have, let's assume, yeah, you can remember the support vector machine I have shown in the in previous slide. Okay, it has a it also has a it was a classification model, but it also has a two types of different data. That is, if we apply a clustering model for that data set, that will predict that data set has two clusters. That is unsupervised learning. We are not giving the model that we are not labeling the output. That in a classification model, basically we are labeling. That means for the previous example, if the student is selected for a job or not, in the data set we have the specific column for the features that student is selected or not for the job. We have the label. From that label, we are training the model in supervised learning. In unsupervised learning, we are not providing that label column. Then we are just giving the data set. We are not providing that label. Then we let the algorithm to decide what are the relationships between this data, what are the clusters, what are the common relationships between these data. Then that algorithm identify what are the relationships. Those two types are different. Then pipelines also different. Pre-processing methods also different. I think I answered your question. Or if you want any more clarification, you can ask. Now I will share the notebooks. I think you guys can see my notebook. Can someone confirm you can see the notebook? You can see the notebook, right? Okay. Uh, in the previous webinar, you learned that uh, you can develop these models using Colab and Kaggle platforms. Today, I will show you how to do it in your VS Code as well. And also, you can, if you like, you can use Colab as well, Colab or Kaggle platforms as well. If you are using a notebook, Google Notebook, Colab Notebook, you just have to go to this Colab platform and uh, use these same exact steps. No any difference. You just have to use that. Okay. And if you use Kaggle, you can go here and create notebook it will create a notebook for you. These all notebooks are cloud-hosted notebooks, and they will provide you GPU facility as well. In the machine learning algorithm training, you don't need much GPU, so it's not necessary to have a GPU to train these models, these kind of models. But if you go further into deep learning and LLM fine-tuning, LLM pre-training, like those kind of thing, you need a you need powerful GPUs. So these cloud-hosted free GPU free notebooks are much better. But for a machine learning kind of thing, it's okay in your local desktop or laptop. You can handle. Okay. Then I will explain how to set up in your local machine as well. You need to have a virtual environment. You know, if you are running a IPython notebook, you need to have a virtual environment. Okay. In this virtual environment, we install all the libraries and packages uh, we need to use in the codes we install in the virtual environment. Using Anaconda, you can download this Anaconda in your laptop and create a Conda environment. Can create a, you can see my Conda environments. You can see I have many Conda environments. You can also create, you can first download Conda, Anaconda for your laptop and then create a Conda environment. And in that environment, you can download these libraries. These are the libraries. sklearn, I will explain what is sklearn, and what this imblearn and pandas, numpy, all those libraries you can install in that Python, Conda environment. The advantage of using Conda environment is you don't need to create environments again and again. In local Python development, you know that you are creating virtual environments again and again for every project. Using Anaconda, you don't have to do that. You just can use one virtual environment for every project. For every project, you can use one environment. That is the uh, advantage of using Anaconda in your local environment. Okay. You don't have to worry this in all these codes you can run in Google Colab. You don't have to set up your local machine for now. You can run all these codes in Google Colab as well. Google Colab or Kaggle platform. In both the platforms, the codes are the same. Okay. First, okay, I will go through the classification model development initially. Yeah. These are the libraries. If you want, you can install the libraries using pip install, pandas, numpy, matplotlib. Uh, I will explain what these libraries do. Pandas is for we can import the data sets like CSV, Excel files, and also read data and process data using Pandas and Pandas library. You can process, read, and all those numerical data handling can be done using pandas. And next one, NumPy. NumPy is also a numerical data handling library. And matplotlib is a plotting library that is used for plotting graphs and all those figures. Seaborn is also a plotting library. Scikit-learn is, I will explain what is scikit-learn. This is the website of skitlearn. Okay, this is the website of skitlearn, and here you can get all the machine learning algorithms. In the skitlearn library, you have all the machine learning algorithms. They have developed the underhood codes, and they have created the library that is easy for you to maintain. Otherwise, you have to develop the models from the scratch. So this skitlearn guys have created the library and make the algorithms, make all the algorithms that are easy to use. Okay, this is that is skitlearn library. And then IMB learn. This is I will explain what is IMB learn in that specific cell. This is missing number. Missing number is this is for getting the missing values in a data set. This library is for that. I will explain that also. Then joblib. This joblib is used to save the final model. You can get the final model. Let's assume we are training a linear regression algorithm. Then finally, using joblib, you can save that finally trained model. You can save the model using joblib library. Okay. I think you can understand all the things. So I will explain in Sinhala if you want as a මේ library එකෙන් එක එක දේවල් කරන්නේ. මේ libraries ටිකෙන් එක එක දේවල් වෙන්නේ. එතකොට මම ගෝවාගේ pandas numpy කියන්නේ ඔක්කොම numerical data handling කරන library දෙකක්. matplotlib එකයි seaborn එකයි ඔක්කොම graph plot කරන ඒ library දෙකක්. ඊට පස්සේ skitlearn කියන්නේ ඔක්කොම machine learning algorithms තියෙන library එකක්. ඊට පස්සේ IMB learn එක මම ඔයාලට කියලා දෙන්නම් ඉස්සරහ cell එකේදී. මිසිං නම්බර් කියන්නේ මිසිං නම්බර්ස් බලා ගන්න පුළුවන් data set එකේ තියෙනවද මොන හරි මිස් වෙලා තියෙන තැන් තියෙනවද කියන එක බලා ගන්න පුළුවන් job lib කියන්නේ model එක save කරගන්න library එක sorry ඔය library ටික තමයි මේ අපේ මේ වැඩේට දැනට ඕන වෙන library ටික තමයි මෙතන තියෙන්නේ හරි ඊට පස්සේ මෙතන තියෙනවා දැන් ඒ here are all the imported libraries and functions from those libraries. I will explain all those functions in the cells. First, let's run this. I am using this conda environment. You can see my conda environment as Python ENE. I have run the cell. You can see it has run successfully. Now you can remember the previous steps that I have explained to you. This one, first one is loading the data. Now, this placement data is, I will show you the data set. This is the placement data. This data set is, as I previously said you about students placing in a job or not. This is that data set. Actually, this data set is taken, I have taken this from our previous assignment. I think in machine learning, yeah, in our machine learning module for assignment, for assignment we have got this data set. Yeah, I don't know whether this time you will get this same data set or not. I don't know that, but we got this. Okay. Yeah. First, that is the data set. This is a CSV file. This is a CSV file, and there are many columns in this data set. Now, using pandas library, you can load the data set. Initially, you have to load the data set. That is the initial step. Okay. Now, load in the data set. You have load the data set and stored the data set in a variable called placement. First one is that. Now you can see here are some explanations in the explanations of the columns that are in this data set. These are the columns. SL number, that means serial number, gender. Then SSCP means secondary education percentage. SSCB, board of education. Like that, there are sorry. Like that, there are many columns. There are many columns in this data set. We are going to predict if a student is going to be placed or not in a job according to the other data given. As an example, if the gender and secondary education and specialization, degree percentage, and all those data given for a given those data, and a student will be placed in a job or not. That is the prediction. That is a classification model development. Okay, can understand. If there are any questions, you can raise. Okay. while I'm talking, you can ask in the chat, or else you can speak up. Yeah. සිංහලෙන් කිව්වොත් මේව තමයි කොලම්ස් ටික. මේ data columns ටික තියෙනවා මේ data set එකේ. මේ ටික තමයි තියෙන columns ටික. හරිද? මේ ටික columns ටික තියෙනවා. මේ columns ටිකෙන් අපි දැන් බලන්නේ මේ ස්ටුඩන්ට් ජොබ් එකකට ප්ලේස් වෙයිද නැද්ද කියන එක ප්‍රෙඩික්ට් කරගන්න. හරිද? ඕක තමයි ක්ලාසිෆිකේෂන්. ස්ටුඩන්ට් කෙනෙක් ප්ලේස් වෙන්නත් පුළුවන් නැති වෙන්නත් පුළුවන්. හරි? ඕක තමයි අපි දැන් බලන්නේ. හරි? Initially, first we are getting the we are using placement.head. This head method is used to get the first five data rows of the data set. You can see there are so many data. The gender column, you have m kind of data. Now SSCP have numerical data. SSCB have other central, like that kind of string data. HSCP has numerical data. HSCB has string data. Like that, there are many data. Now you can't decide what to do. No, you can't decide how to use these data to feed the model. You don't know what are the features that are more relevant. Are there any features that you have to drop, or else you have to remove? Are there any missing values? You don't know anything. So EDA is the most important thing. Using exploratory data analysis, you are analyzing the data set. You are analyzing the full data set, that what are the relationships and what kind of data we are having in this data set, and what are the how the graphs look like. Are there any missing data? And like that you have to analyze all the relationships and missing or anything, any kind of relationships in this data using EDA. This is the EDA part. First, using head, you can see the initial 5 rows. Okay. Now you use info method. Using this info method, you can see the data types of the columns. Using this info method, you can see the data types. Now you can see SL number is a integer. Gender is a object. That means that's a categorical value. Object is a categorical value. Okay. SSCP is a floating point value. SSCB is object. Like that, there are numerical and categorical values. Numerical and categorical, both the values are present in this data set. Now you know that. Okay. Now we get the length of the placement data. Okay. From the length, you know how many rows are in the specific data set. You can see that now there are 215 data in this data set. Okay, there are only 250. There are not many data, but this is a bit enough for to train a model. Not it is better if you have many data, but in this data set it is just having 215 data. Okay. Next one, you are dividing the data to categorical features and numerical features. You have to process these features differently. You know, categorical features you can't process like numerical. No. Categorical features, there can be as an example, gender is male or female. That is not numerical. No numbers. Numerical features, yeah, you can process numerical features. Now we get numerical and categorical features. You can see there are 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 categorical features and 7 numerical features. Okay. Actually, in categorical features, you can drop this status. Status column is the prediction value, prediction column. That is that column you don't take for the training data. For the features, status column is the prediction column. That is not a feature. Okay. Features are these columns: specialization, work X, degree, HSC, these, and SSCP, HSCP. These are the features, and this status is the prediction column. That is different. Okay, that is the label of our data. This is the labeled column. Status column is the labeled column. Okay, then processing numerical data. Yeah. Using this describe method, you can get the mean, count, standard, and minimum, and quartile, and 50% value, and maximum value, all the values of the numerical data, only in the numerical data. From this describe method, you can get the numerical values relationships. You can see the counts are SL number has 215 count. All these have 215 count, but salary has 148. Now you know salary has some missing values. You got one relationship from that. Now you know that salary has some salary. There's something wrong with the salary column. You know that now. Okay. Now let's go to plots. Here's a plotter class I have created. Don't worry about this code if you don't familiar with Python. Don't worry about the codes. You just have to know about these methods only. Using Seaborn. Here SNS is Seaborn library. I have previously said that this is the Seaborn library. This is used for plotting. Now, sorry. Using Seaborn's box plots, I am going to plot the box plots of the, you can see, I have plot the box plots of the numerical values. You can see all the numerical values, SL number, and another thing, SL number is the serial number. You know that the serial number is nothing to do with the student getting placed to a job or not. You can drop that column initially. You know that serial number is just a number. That is an index now. So you can neglect that column initially. Okay. I have taken that column as well, but you can drop that column if you want in the beginning as well. Okay. I will drop this column in later part, but initially also you know that serial number is nothing to do with the classification. So you can drop that as well. Now you analyze other relationships. You can see this data is okay, fine. There are no outliers. Seems to be fine. But in this one, there are some outliers. You can see there are some outliers. In box plots, you know, the outliers are these outliers are much deviated from the actual data. That are the outliers. මේ outliers කියන්නේ මේ අපෙන් තියෙන normal data වලට වඩා ගොඩක් deviate වෙච්ච data. ඒ කියන්නේ ගොඩක් වෙනස් data. හරිද? Now you can see in salary there are many, right? There are many outliers. Now you are sure that salary column has something to be changed, and we have to process that column. You know that for sure now. Okay. Now we go to categorical data. We have processed we have analyzed the numerical data. What are the numerical data? What happened to that? And what are the counts and mean, standard deviation, and what are the things like that? And now we go to categorical data. You previously know that there are 8 categories, categorical features. Now you know, but you don't know what are the values inside that. In categorical data, you know gender can have only male and female. Okay, but you don't know what are the others. SSCB, what is that? We don't know. HSCB, what is that? You don't know. Like that, then you have to analyze these. What are the value counts in this? Okay. First, let's find gender. This is gender column has male and female. You know that it has only two categories, male and female. Then SSCB. SSCB column has central and others. That is also having two values. Then HSCB. You run this column, you run this cell. Now that is also having only two values. Okay. Then HSCS. That is having three columns, three types of data: commerce, science, and arts. And the next one is degree T. Degree T has commerce and management, science and tech, and others. Work experience, two values. Specialization, two values. Status, placed and not placed. This is our prediction label. You know that this is our prediction label. Okay. This is just for the this is just a mapping used to get the actual meaning of this summarized data. Okay. Now let's this code is also a summary of the above. We have initially get line by line. We have analyzed this by column by column. This is the summary of that analysis. Okay, this is the summary of the analysis. Degree T has three values. Gender has two values. Like that. This is a summary. Now you are going to further analyze the data set. ඔගොල්ලෝ තව ටිකක් මේක analyze කරන්න තමයි යන්නේ. හරි. Now we are using count plot. You know that count plots. Okay. Here are the plots. You can see, you know that SL number, you know that you can drop that column, so you don't worry about that column. Then gender is a new categorical value. It's fine, but not balanced. It's fine. Okay, this is also numerical value and distributed, so it's fine. SSCP column also fine because it is distributed. Okay, this is categorical, fine. HSCP distributed, fine. And this also all these features are fine. But when you comes to salary, again you know that, again you can see that this is skewed. Skewed means this is not symmetrical. The graph is not symmetrical. Now you surely know salary column has something wrong. You have to process that column. Okay. Now let's this is the status column, and this is very important. This is the most important thing. You have to check the label data. Check the label column is balanced or not. Can someone say if this data is like this, this placed have around 150 and this not placed have 70. If we train the model using this without processing anything, if we train the model like this, what happened to the model? Can someone say? This is very important. In a classification model training, what happens if we train the model as it is? Can someone take? Yeah, exactly. The model will be biased. Model biased. The model will be biased. So what can we do to remove the biasness from the model? What can we do? What are the things that we can do to remove the biasness from this data? Very simple answer. This is unbalanced. This data is unbalanced. We have to, yeah, we have to balance the sample. We have to balance the data set. Yes, correct. Now, this is the most important data we have gathered from this plots and EDA. This is the most important data. We know that the data set is biased for the placed part. For the placed classification, the data set is biased. So to remove biasness, we have to do something. That is very important data we have gathered from the EDA. Okay. Next, we draw some more plots as well to understand what are the relationships of data and are there any relationship of these data of the data in the features, are there any relationship or not. We are drawing some graphs. This graph is for status and status according to the gender. You can see men, uh, okay, yeah, most placed and not placed are men. You can see there's a relationship. Okay, in this also you can see there's a relationship, and also you draw draw for numerical values as well. Here also you can see there is some kind of relationship. The graphs are okay, no? The graphs don't the graphs are not skewed. The graphs are all symmetrical. So you can say there can be some kind of relationship between these data. Okay. Now further, that are, yeah, from that, yeah, that is all for the plotting. Now we know from the plotting we have understood what are some relationships and what happened to the prediction class. That is the most important data we have gathered from the EDA part. The class is unbiased. Sorry, unbalanced. Then the model will be biased. If we train the model as it is from this data set, then the model will be biased. We know that. Now, we further analyze using some more functions. Here, we check, are there any null values? You knew that from the graphs as well. There are null values in the salary column. Okay, now you are sure that there are 67 null values in the salary column. For further analysis, you use MSNO, missing number library. I have previously mentioned from this missing number library, missing number dot matrix, and using this data frame, you can get this graph. From this graph, you can see in these columns there are no missing values, but in the salary column there are so many missing values. Okay. Now we have to check the duplicates. The duplicates also not suitable for model training. That is also, we have to remove the duplicates, remove all the duplicates. We are not giving duplicates to the models. That will also tend to bias the model. So we are not providing duplicate values as well. Here we are checking for duplicates. There are no duplicates, so it's fine. We are proceeding further. Now we look for correlation. Correlation means, I will explain what is correlation. Here is the correlation. You can get the correlation heat map only for numerical values. You can get that for categorical value. If you encode the categorical values, you can get, but here I have just get for the numerical values. I will explain what is this, what this heat map says. If the heat map has more than yeah, I will explain this. A correlation heat map in machine learning is a graphical representation of a correlation matrix that shows the strength and direction of the relationships between multiple variables in a dataset. The heat map uses colors to visually represent these correlations. Typically, warmer colors indicate strong positive correlations, cooler colors indicate strong negative, and neutral colors indicate weak or no correlation. Now, you can see using a SSCP and HSCP, there is a positive correlation. That means if you increase SSCP, HSCP also increase. And you can see degree P and SSCP. When you increase degree P, SSCP will increase. You know that there can be some relationship between these features. You know that. You draw this heat map to analyze the correlation between features. All the available features, what are the correlation? If there is a relationship between those features. Now you know that some features are correlate with other features. Okay, you proceed further, and you can draw a scatter matrix as well. Yeah, that is just for visualization. No need to analyze this. Now we come to the most important part. You know that. Can someone tell me why we pre-process data? Why we pre-process the data? If you know, if someone know why we pre-process the data before feeding the model. There can be many reasons. Yeah. Can you explain at least one? No, no need to explain. Can you say at least one? Why we pre-process data? You know that this dataset contain many categorical values, many numerical values, so many types of data. Why we pre-process? And what is pre-process? Can someone tell? සිංහලෙන් ඇහුවොත් ඔයගොල්ලෝ දැන් උඩ අපි EDA එක කරන් ආවනේ. මේ EDA එක කියන්නේ exploratory data analysis එක. මේ data analysis එකේදී ඔයගොල්ලෝ කරන්නේ මම සිංහලෙන් මේ ටික කිව්වේ නැහැනේ. මේ EDA එකේදී කරන්නේ මේ ටිකේ මේ ඕගොල්ලෝ ගත්ත data set එකේ මොනවද තියෙන relationships කියන එක හොඳටම අපි analyze කරලා බලමු. මොනවද තියෙන relationships? හරිද? දැන් මේ relationships වලින් ඕගොල්ලෝ ගත්තා. දැන් මේ categorical values මෙන්න මෙයා values තියෙන කියලා ඕගොල්ලෝ දන්නවා දැන්. හරිද? ඊට පස්සේ දැන් මෙතනට આવොත් මෙතන ගත්තොත් මෙතනත් දැන් මේ ටික තියෙනවා. දැන් මේ graph ටික අවුලක් නැහැ. මේවා symmetrical හරි ප්‍රශ්නයක් නැහැ. එතනින් ඉස්සරහට යන්න පුළුවන්. මෙතන ඔන්න salary column එකේ අවුලක් තියෙනවා. එතනිනුත් ඔන්න අපි ඉස්සරහට ගිහින් බලමු එහෙනම් මොකද්ද කරන්න පුළුවන් salary column එකේ පොඩි අවුලක් තියෙනවා කියන එක ඔන්න ඔලුවට යනවා දැන් මේ ටික ඇඳලා පස්සේ. හරිද? ඊට පස්සේ ඔන්න මෙතනට ආවට පස්සේ අපි බලනවා දැන් මේ අපේ දැන් තියෙනවානේ මේ මොකද්ද prediction column එක. prediction කියන්නේ label column එක තියෙනවානේ අපේ දැන්. status එක තියෙනවා. ඒ කියන්නේ place the not place the කියන එක තියෙනවා අම්මට. මේක ඇඳලා පස්සේ මෙන්න මේක balance නැහැ. ඔන්න දැන් ප්‍රශ්නයක්නේ. දැන් මේක බැලන්ස් නැති වුණොත් එහෙම අපි මොඩල් එක ට්‍රේන් කරලා වැඩක් නැහැ. ඔන්න දැන් ඔයගොල්ලෝ ඉස්සරහට ලොකු අයිඩියා එකක් ගන්නවා. මෙතන මේක ඉස්සරහට යන්න බෑ අපිට. අනිවාර්යයෙන්ම මේක බැලන්ස් කරන්නම වෙනවා. ප්‍රී ප්‍රොසෙසින් පාර්ට් එකේදී අනිවාර්යයෙන්ම බැලන්ස් කරන්න වෙනවා. නැත්නම් වැඩක් නැහැ. හරිද? බැලන්ස් කරන මෙතඩ්ස් එතකොට ඔයගොල්ලෝ කල්පනා කරනවා බැලන්ස් කරන්න මොනවද කරන්න පුළුවන් දේවල් කියලා කල්පනාත් කරනවා. ඉස්සරහට යනවා. හරිද? ඊට පස්සේ තව ඔය වගේ graph ටිකක් ඇඳලා තව බලනවා මේ relationships තියනවද නැද්ද මොනවද වෙලා තියෙන්නේ. ඊට පස්සේ ඔන්න මේ වගේ summary එකක් අවශ්‍ය වුණොත් ලියා ගන්නවා. එහෙම මොනවා හරි තියනවනම් ඊට පස්සේ බලනවා null values තියනවද කියලා. නෑ ඔයගොල්ලෝ දන්නවා null values උත් තියෙනවා මේ salary column එකේ පොඩි අවුලක් තියෙනවා. ඊට පස්සේ බලනවා correlation matrix එකකුත්. මේකෙන් බලන්නේ feature අතර මොනවද තියෙන relationships කියලා. ඔයගොල්ලෝ මේ සමහර features වලින් පේනවා මේක වැඩි කරද්දි මේකත් වැඩි වෙලා තියෙනවා. එතකොට දැන් මේ අතර relationship එකක් තියෙනවනේ. ඒක නිසා ඔයා දන්නවා දැන් මේ data set එක අවුලක් නෑ මොඩල් එක train කරගන්න. මොකද data අතර පොඩි relationships තියෙනවා. ඒක නිසා මොකක් හරි හොඳ relationship එකක් තියෙයි. දැන් මොඩල් එක train කරාට පස්සේ හොඳ relationship එකක් මොකක් හරි තියෙයි. කියන එක ඔයගොල්ලන්ගේ ඔලුවට යනවා. හරි. එතනොත් අපි ඉස්සරහට ගිහිල්ලා හරිද? තව ඕනනම් තව graph එකක් ඇඳලා බලලා මොකද්ද වෙන්නේ කියලා බලලා ඔන්න අපි යනවා pre-processing වලට. හරිද? දැන් මම අහන්නේ මොකද්ද ඇයි අපි pre-processing කරන්නේ කියලා මම ප්‍රශ්න අහනවා. Why we do pre-processing? Before feeding the model to the before feeding the data to the model, why we do pre-processing? Can someone answer? This is very important. This is the most important part. After EDA, this is the most important part. Before training the model is very easy. EDA and the pre-processing is the most difficult and most crucial parts. Okay. Training a model is very easy. That's just 2 or 3 lines. But pre-processing and EDA, that is a hell of lines. There are so many lines and so many codes, so many analysis. Okay. Someone has answered. Okay. To convert the non-numerical data into numerical data. Okay. Yeah, kind of true. Yeah. Okay. Yeah, ML models and no, not ML models. Actually, computers can only handle numerical data. You know that only computers can handle numerical data. If you provide a machine learning or a computer to understand male and female from the strings, male and female, can he understand? Can the computer understand? No. The computer can't understand the letters male and female. He can't understand. We have to convert all the things to numerical values. Now we have to process the categorical values to numerical values. That is one use of pre-processing. Okay. Other pre-processing is we have to clean the data set. Cleaning also another thing. And also there are many types of the pre-processing also can be divided into sub-processes. I will explain now what are the sub-processes. Okay. The answer is correct. Okay. Now, first, data splitting. Now you know from your data set, you can't give all the data to a model. Then how can you test the model? The model is giving the correct answers or not? You can't test. To test the model, you have to split the data. You know that? You have to split the data. You can't give all the 215 data to the model and then you don't have the real world data. In this data set only you have the real world data. Then you have to divide this data set into 2 parts. One is training set and one is testing set. In the testing set, no need to have many data. The usual practice is 0.8 to 0.2. 0.8, that means 80% of data is to training the model and 20% is for testing the model. Like that, we are now splitting the data. Okay. First, we take a copy of the data. For the df variable, I will take a copy. Without changing the initial data set, I will take a copy. Okay. Now, we know that why we drop this status. For this x and y are, x is the features, y is the prediction column. In the prediction is, you know that prediction column is the status column. And x is the features. From the features, you have to drop the prediction column. Prediction column is not related to, prediction column is not a feature itself. Okay. ඒක feature එකක් විතර ගන්න බෑ. ඒක feature එකක් නෙමෙයි. feature එකක් කියන්නේ ඒ prediction column එකට බලපාන අනිත් එකට තමයි අපි features කියන්නේ. එතකොට අපි prediction column එක drop කරලා තමයි features ටික ගන්න. එතකොට you can see I will run this. It has run successfully. Now we split the data using train test split method. In this scalar library, you can get this pre-built method. I have initially said that in sklearn you can get machine learning models and these train test split methods, and there are so many helper methods they have developed. You just have to import them and use. You don't have to code from the scratch. You have all the inbuilt libraries using sklearn. You can import the method and you can use it. Here, this train test split method split the dataset into training and testing parts. I will run this. Now you can see the length of X test is 43 and X train is 172. Okay, it has uh, it has split into two parts. Okay, now this is the shape of the X train. X train shape means 172 is the row count and 14 is the column count. We still didn't drop the SL number. We can drop it in the next cell. Okay. Now, first one is data splitting. The next one is data cleaning. Still, we didn't clean the data. Okay. We we have initially explored the data. In EDA, we didn't do anything. We didn't do anything for the columns. Okay. Initially, we just analyze what are the data, what happened to this data, what are the relationships. We didn't touch the data. Okay. Here in preprocessing, we are doing all the things to the data. We are dropping columns, we are imputing. I will explain what is imputing. Um, we can do anything. Okay. In preprocessing, we have to do all the necessary things to feed before the model. Okay. Now, in data cleaning, handling missing values. I will explain what is handling missing values. In handling missing values, you can do three things. You know that in salary column, there are missing values. You can do three things. One is you can drop the column. You can drop the whole column. You can drop the salary column from a feature. Then that will reduce a feature. If we have about I think 10 or 13 or 14 features now, then dropping a feature is also fine. It's also okay. Or else you can impute with mean, median, or mode. You know what is mean, median, mode. You get the mean, median, or mode from the other data. That means if the data set in the rows, the column is empty, the salary column, some parts are empty, but some parts have data. Some parts have data, but some part is empty. From the available data, we are getting the mode, median, and mean. From those values, from one value, you can't take all the three values and fill the rows. You can't do that from taking only one value. Or if median, you are taking median, you can fill from median. If you are taking mode, you can fill from mode. If you are taking mean, you can fill from mean. Like that, you can impute. Imputing means you can fill the data. That is imputing. Simply imputing is you can fill. And also, for a categorical one, you can impute the categorical columns with the most category. With the as an example, let's say in the gender column, there can be some missing values. In this data set, there are no missing values, but let's assume there were some missing values. Then we analyze what is the max value. That means male or female, what are the max? Then if the male is the most data, then we fill from that most data. Like that, you can do that. Okay, that is the thing, how to handle missing values. That is how you handle missing values. Now, uh, from the training side, you are first going to drop the duplicates. Now you know there are no duplicates. So you are using this method, but you know that there are no duplicates. From the EDA part, you know that there are no duplicates, uh, but you somehow use the method. No harm for the data set, but you know that there are no duplicates. Okay. Then you know that serial number is not necessary for the prediction. You are going to drop that from the training set as well. Okay. Next one is then here the salary column. This is the most problematic column. In this column, you can fill the column with the median value, or else you can drop the column. You can do both. Here in this commented codes, you can see I have filled the column with median value. Okay. But here it is, we are dropping the salary column. You can do both. Here I'm doing the dropping thing. Okay. I will drop the salary column. Okay. Now you can see there's no salary column. Okay. Now feature encoding. Now you have dropped the data and not balancing. You have analyzed the data. You have seen what are there any duplicates, are there any null values. Now you have handled all those things. Now next we go to feature encoding. Here the feature encoding is also very important. Feature encoding means you know that in the features there are categorical and numerical values in our data set. In these categorical values, I initially said that the categorical values cannot be processed by the computers. Okay, you have to convert to numerical values. That is basically encoding. This is encoding. Okay, encoding means converting the categorical values to numerical values. That is encoding. Okay, very simple. There are I will explain two encoding methods. There are another encoding methods as well. You can do your own encoding as well. There are inbuilt libraries, inbuilt encoding methods. I will explain two encoding methods. First one is ordinal or label encoding. This is for converting categories to integer labels for ordered categories. This is for ordered one. Let's say you have category and you have the values as low, medium, high. Then you know that there's an order, low, medium, high. You should have an order now. Then you are using label encoding. Label encoding means 0, 1, 2. Then using that label encoding, you preserve the order. You have to preserve the order. There is an order. Then you use 0, 1, 2. Low for 0, medium for 1, high for 2. That is label encoding or ordinal encoding. Now, the next one is one-hot encoding. This is for no order. This is just for you can say there's a red, blue, green, three values, three categorical values. There's no order. There's no order. These are three independent values. Then you can say you can use one-hot encoding. That is just an 0-1 array. This is a 0-1 array. Convert to a 0-1 array. 0-1 of three count of 3, array of 3, 0-1. Only 0-1 having array. Okay, that is one-hot encoding. Now, here we are using label encoder. For our objects, we are using label encoder. Okay. You can see I have used fit transform and transform. Okay. These methods are different. Okay. We use fit transform for training data and we use transform for testing data. Okay. We use fit transform for training data, transform for testing data. You have to carefully remember that we use fit transform to training, transform to testing. Okay. Now we encode the columns. Now I will show you what happened to the columns. Now you can see all the categorical columns have become numerical values. You can see gender has become 0, 1. SSCB has become 0, 1. HSCB has become 0, 1. Here HSCC have 0, 1, 2. Like that, it has become numerical values. That is encoding. Okay. Then we go to handling class imbalance. Then this is the another very important thing, because in previously we knew that testing, sorry, not the testing. Previously we show that we have seen that our prediction column is unbalanced. It is not balanced. Okay. It's a problem to training the model. Then we are going to use SMOT. This SMOT is a inbuilt library. It's a library. You have to use SMOT. This SMOT is a this will actually generate new data. Okay. This will do is generate new synthetic samples. You can see the class, first class is place class, and the next the reduced class is not place now. Then not in not place class, this will increase the data using generating. This will generate new samples. Using this library, I will generate new data and balance the data set. Now you can see this is before resampling and after resampling. Now you can see the status is balanced. Now you know you are good to go. You are good to train the model. Okay. Now feature scaling. Here the feature scaling is done if you have many outliers. Then you have to do the feature scaling. Okay. You know that in salary column we had outliers, and also there was another column that had outliers. we have dropped the salary column, so no need to actually scale the model, scale the data, but I will scale this. No harm no harm if you scale or not, no harm, but scaling is better. Okay, scaling the model is better. Sorry, scaling the model, not the model, scaling the data, scaling the features. Okay, can see. Now I have scaled the data. This will scale all the data. Okay, these are the box plots. Now you can see there are very small amount of outliers, but it's okay. Okay. This one also used to get outliers. No need, because we have analyzed the outliers before. This DB scan library is also used for getting the outliers. So no need to do that again. Using the standard scaler. Sorry, here I have just get the not scaled in this cell. I have not scaled this in this cell. I have just plotted the data. Plotted the data to check whether there are outliers. You can see there are outliers. Now I am going to scale. I am using standard scaler. You can import that as well using libraries. You run this. That is for the pre-processing. Okay, I will explain in Sinhala as well. මෙතන pre-processing වලදී දැන් ඔයගොල්ලන්ට pre-processing වලත් තව sub parts ගොඩක් තියෙනවා. හරිද? මුලින්ම අපි split කරනවා data. කඩා ගන්න බෑ data. ඔයගොල්ලන්ට ඔක්කොම data ටික produce කරන්න බෑ model එකට. ඒ නිසා අපි data මුලින් කඩා ගන්නවා. හරිද? data කඩාගෙන testing වලටයි training වලටයි බෙදා ගන්නවා. හරි, ඊට පස්සේ clean කරනවා. duplicates තියනවද බලනවා. duplicates අපි දන්නව නැහැ කියලා. ඒකට අපි බලනවා තියනවද කියලා. කොහොමදත් තියනවද කියලා බලනවා. හරිද? ඊට පස්සේ unnecessary column එකක් අපි දන්නවා SL number කියන එක වැඩක් නැහැ. ඒක අයින් කරලා දානවා. හරිද? මෙතන salary එකත් අපිට ඕනනම් median වලින් දාන්න පුළුවන් median එකෙන් fill කරන්න පුළුවන් impute කරන්න පුළුවන් මම ඒනවට impute කරේ නැහැ drop කරා හරිද drop කරන්න නැතුව ඔයගලන්ට ඕන නම් කැමති නම් impute කරලා බලන්න පුළුවන් ඒ කියන්නේ accuracy එකේ වෙනසක් තියෙනවද කියලා ඔයගලන්ට මේ check කරන්න පුළුවන් මේ එක එක දේවල් කර කර බලන්න model එකේ accuracy තියෙනවද කියලා accuracy කොහොමද වෙනස් වෙන්නේ සමහර විට මේක drop කරන්න නැතුව මේ ඔයා මේක impute කරලා median එකෙන් impute කරලා එන model එකේ accuracy එක වැඩි වෙන්න පුළුවන් ඒක කියන්න බෑ ඔයාලට කරලම තමයි බලන්න හරි ඊට පස්සේ තව ඉස්සරහට ගියොත් encoding කියන්නේ කැටගරිකල් ඒවා නියුමරිකල් කරගන්න එක ඊට පස්සේ ක්ලාස් ඉම්බැලන්ස් එක හැන්ඩල් කරනවා කියන්නේ මේ ස්මෝට් ලයිබ්‍රරි එක යූස් කරලා මෙයා data generate කරනවා data generate මේ ස්මෝට් කියන ලයිබ්‍රරි එකෙන් data generate කරනවා මේ generate කරලා ඔයා අර අඩු ක්ලාස් එකේ values ටික වැඩි කරගන්න එක තමයි ස්මෝට් එකෙන් කරන්නේ හරිද ඊට පස්සේ මෙතනත් බලනවා දැන් හරි after resampling අවුලක් නැහැ ස්මෝට් එකෙන් data වැඩි වෙලා තියෙනවා දැන් sample දෙකම balance වෙලා තියෙනවා ප්‍රශ්නයක් නැහැ අවුලක් කියලා නැහැ ඊට පස්සේ ඔයා බලනවා ආපහු මෙතන චෙක් කරලා බලනවා අවුට්ලයර්ස් කොහොමද කියලා ආපහු කලිනුත් බැලුවා අවුට්ලයර්ස් උනට ආයි දැන් බලනවා අවුට්ලයර්ස් කොහොමද තියෙන්නේ කියලා දැන් අවුට්ලයර්ස් ටිකක් තියෙනවා මෙතනනොත් මේ DB ස්කෑන් එකේනොත් අවුට්ලයර්ස් චෙක් කරන්න එකත් එච්චර ඒක වැදගත් නැහැ ඊට පස්සේ ස්ටෑන්ඩඩ් ස්කේල් එක යූස් කරලා ස්කේල් කරගන්න හරි මේක තමයි ඔන්න ප්‍රී ප්‍රොසෙසින් මෙතඩ්ස් ටික ඔතනින් ඉවර වෙනවා හරි ඊට පස්සේ එනවා feature engineering when it comes to feature engineering in this data set no need to do feature engineering I will give you the examples of feature engineering in some data set you need to do feature engineering as well okay let's assume there are no relationships in the data in the features in the given columns you don't have any relationship there can be sometimes there can be no relation when you draw the heat map or correlation matrix or anything you can't see any relationship then you wonder how I can train this model there will be no relationship for sure if you train the model the accuracy will be definitely lower value so you have to do feature engineering means you can from the existing columns you can merge or else you can expand the columns you can increase the columns as an example let's say you have a in a machine learning problem you want to predict the let's say you want to predict the stock prices you want to predict the stock prices then in the given features you don't have any relationship but you have a timestamp for a given one you have a timestamp but in the timestamp you can divide that timestamp into many things now you can get one column as year one column as month one column as day and you can also get the week of the month and also uh, what is the stock prediction happen in the morning or the evening in the day like that you can engineer that feature that is feature engineering you can increase the columns from the existing column or else you can reduce the columns from existing column that is feature engineering in this data set there's no need to do that I have explained that if you you will be needed this in your next when you go to industry or anything feature engineering can be used okay now we have come to the last one train evaluate and hyperparameter tuning okay now can someone explain what is hyperparameter tuning anyone know what is hyperparameter tuning has anyone heard about what is hyperparameter tuning or anyone I think no okay I will explain what is hyperparameter tuning I have initially said that okay there's a one models parameters like constants So models parameters like constants. I'm not clear. Can you explain a little bit? Not necessarily constants. Okay, I will explain. You can see I have defined here. I'm using support vector classification model and linear regression model. Okay, in these two classification models, I am using these hyperparameters. One is C, and the other hyperparameter is kernel. Here the degree. This is for support vector classifier, and for the linear regression, this is all. It also has the C as the hyperparameter and solver and penalty. You can get the all these hyperparameters from this SKLN website. You can know because they have the ones who they are the ones who develop these models, so they know they have included all the parameters to tune these models. They know that these parameters will tune the model by changing these parameters. This will tune the model like that. They have included all these parameters. By using some of these parameters, you can get some values. You can assume some values, and you can give you can give like this. You can give like this in an array. These these values should be suitable for this. If the solver is like this, solver is this kind of values, then you can't give 1 2 3 4 5. You can't. You have to go to the website and get what are the data suitable for the parameter. Okay, you have to get the values we should provide to that parameter. You can't get any value. You can't use any value to use the parameter tune. Okay, you can get that from the website only. Okay, okay, I have get that from this from the SKLN website and use these parameters to train these two models. Now I am getting the SCC model from the SKLN library and logistic regression model from the SKLN library. Now I am using grid search CV. This grid search CV iterates through the parameters. That means it iterates through the parameters and get the best parameter. It iterates through the data set. You are providing the data set now. You are providing the data set, final data set. Then it goes through the provided data set with these parameters and check what is the best parameter, what is the best parameter giving the best accuracy. It will get that. That is the grid search CV's part. Okay. Now I will use grid search CV and then I will fit the data. For the grid search CV, I will fit the data. This is the final resampled data I have pre-processed. These are the final data. You can see it will fit. This will take a time. This will take a time, and it will give the best models. It will give what is the best for linear logistic regression, what is the best for support text classification. Now we get the cross-validation scores as 82.01 for SVC and logistic regression as 84. Now we are printing the best parameters. What are the best parameters that they have got? You can see support vector classifier, it has got 100 for the C, degree for 1, poly as the kernel. These are the tuned parameters. These are the tuned parameters. Okay. Logistic regression also the same. Now using this is the best final model. You can see using these hyperparameter. This is the final best model. This is the final best logistic regression model. Now we are predicting from the test. Now we get the test accuracy. We are from the to measure the accuracy. We have to predict for the test data now. We can't get accuracies without predicting for the test data, because test data is the unseen data. The model has not seen the test data previously. So giving the test data, we can get the actual accuracy. That means unseen data's accuracy. You can get that. You can see support vector classifier is giving 72% accuracy, and also linear regression, logistic regression also giving the same accuracy. Then you can see both the models are good. Okay, this is the confusion matrix. You can see this is the support vector classifiers confusion matrix, and this is logistic regressions confusion matrix. Okay, this confusion matrix. Okay, I will explain this as well. Oh, okay, 856. Okay, I will explain this one and stop. I thought that I could be able to do the regression one as well. I don't know. I think I can't do that. I will give you the notebooks and you can go through the notebooks. I will not do the regression one. I will complete this one and end the session. Okay, true positive. Here, true positive value is the these values we are taking just for the classifications. We are taking these true positive values, true negative, false positive, false negative values only for classifications. Okay, this true positive value is the model predict the positive and the actual class is also positive. That is okay. That is like accuracy. That is the accuracy. It is actually accuracy. Okay, true negative. The model predicted negative and the actual class is also negative. That is also fine. Now false positive. The model predicted positive, but the actual class is negative. Okay, and false negative, the model predicted negative, but the actual class is positive. Here these are four types of accuracy measurements. We are not taking accuracy, that means true positive, always, because as an example in medical field, uh, rather than accuracy, rather than getting true positive, we are getting uh, false negative. False negative value as the best. We are getting the models false negative to evaluate the model, because if the model predicted negative but the patient is positive for something, the model predicted negative but the patient has something very dangerous, that is not acceptable in medical area. So these four types of accuracy measurements are used in separate fields. Okay, that is that is how you train a model and get the accuracies. And finally, using this job lib, you can drop the models and get the accuracies from those saved models. This is the end of this file. Okay, I hope I was ready to do this one as well, regression one, but the time is enough. Time is not enough. I will provide you the notebook and you can go through this and you can run this notebook as well. Go through this notebook as well. There are feature engineering parts in this one. Okay. I have not used feature engineering in the classification model, but in this regression one, there are feature engineering parts. So it's better you can go through this before the competition. So I will, okay, I will end the session now. Okay. If there are any questions, you can ask. You can ask them. If there are any type of questions, ask. Not necessary for the machine learning. Are there anything related to AI or something? You can ask. Are there any questions? Oh yeah. Someone is asking a question. Could you share some real world examples in Sri Lanka where regression analysis could be applied effectively? Yeah. There can be many fields. Uh, Mainly in weather analysis you can use. In our final year, not in our friends, one of our friends final year projects also, they are using machine learning models to regression analysis, machine learning model to predict the rain using the using some temperature sensor data like using some sensor data like temperature sensor data and humidity sensor data, and also there are some kind of sensors like 3 or 4 sensor data. uh, they are getting that one, and using a machine learning model they are predicting the rain. That is weather analysis. You can use that in a real world scenario. And also there are many fields like mm, you can get agriculture crop prediction and tourism tourism in tourism also you can get tourism revenue predictions. Those are also real world examples. I think in most cases you can use regression analysis if if you have data, if you have past data, then you can use the regression analysis. That's fine. Past numerical data, then fine. since Smart generates data, can it go? Yeah, yeah, definitely. Generating data is not necessarily a good method. If you can uh, have a data set, if you have an actual data set with balanced data, that's the best way to train the model. Generating synthetic samples will uh, cause problems in the models. Yeah, that's true. Because those synthetic samples, those smart models also machine learning models, no? Then the error will propagate. If you can create your own data with balanced samples, that's the best way to train the models. Are there any more questions? Dinit, I think I have answered your question, right?
A big thank you to Mr. Dinuk Patiraja for delivering such an engaging and insightful session. Your expertise has added great value to today's webinar. To deliver the vote of thanks, now I invite Ms. Punsara Sevwandi, co-chair of Eminence 5.0 IEEE WIE Affinity Group, University of Ruhuna. Ms. Punsara, over to you.
Good evening, everyone. As the co-chair of Eminence 5.0, I'm so happy to give the vote of thanks for this special event, the third webinar of our Eminence 5.0 journey. So first, on behalf of the WY Affinity Group, IEEE student branch at the University of Ruhuna, I wish to extend our heartfelt gratitude to Mr. Dinuk Pratirasha for taking the time to share such a valuable insights with us today. Right now, we would like to present a token of appreciation to you, Mr. Dinuk, as a small way to say thank you for your time and support for Eminence 5.0. And next, I would like to sincerely thank all our participation for being with us today with such enthusiasm. Your active presence makes this event truly meaningful. And also, a special thanks goes to our organizing committee for your commitment, hard work, and dedication behind the scenes, ensuring this event was a success. Together, we have made today a valuable and memorable experience. Thank you once again, and we look forward to meeting you at our future webinars as well. So, thank you, and it's over to you, Vihangi.
Thank you, Ms. Punsara. We are now sharing a feedback form in the chat. Kindly take a moment to fill it out and share your valuable feedback with us. To end today's session on a memorable note, let's capture this moment with a group photo. I kindly request all participants to turn on your cameras so we can take a snapshot together.
කවුද වගේ කියලා මේ හිර වෙලා තියෙන්නේ පොඩ්ඩයි ගා මොකක්ද
Finally, I would like to thank everyone for your active participation and enthusiasm throughout today's session. Your engagement made this webinar truly successful. We hope you found it informative and inspiring, and we look forward to welcoming you to our future sessions in the Eminence 5.0 series. With that, we conclude today's session. Thank you all and good night.